Hello, today we have another interesting question, which is LC 128. It's a medium question. Given an unsorted array of integer nums, return the length of longest consecutive element sequence. So it unsorted array, we have to return the length of longest consecutive, and the algorithm must run in O of n time. So let's write down the example. 100, so it says 100, 4, 200, 1, 3, 2. And the output is 4. How is it 4? So the longest consecutive is 1, 2, 3, 4. So this is the longest consecutive. Now, in the constraint, it says that nums can be minus 10 to the power 9 to 10 to the power 9. So it can be negative as well as positive, does not matter. So if we had a minus 1 or 0 here, so it will be 6 because it will be minus 1, 0, 1, 2, 3, 4. So we have to do it in O of n time, right? What could be approach if we are not given this O of n time constraint would be we go to 100, we check if there is anything less than 100, we check if there is anything greater than 100. If any of them is true, then we go to that element, we check if there is anything less than 100, we keep checking until the least number. If there is anything greater than 100, we keep checking until the max number. Now this while this is a good idea, this can be a little bit optimized. Suppose, suppose for 100 we're checking at 99, we're checking at 101, right? So if 100 already has a element called 99, we for 99 we will also check for 98 and 100, right? So if 99 is always already present, we are already checking for 100, so we don't need to check for this 100. So either we go all the way down or we go all the way up. So if we go all the way down, if there is anything, so if there is anything minus 1, I mean less than one position of 100, we will just skip 100. We don't need to do 100. What we'll do, we'll start with 99. And then 99, we keep going up, that we keep checking. So I'll explain with the 1, 2, 3, for example. So when we first go to 100, we check if there is anything less than 100, there is not. So if there is nothing less than 100, if there is anything greater than 100, there is not. So we skip it. For 4, we check if there is anything less than 4. Sorry. If there is anything less than 4, we find 3, we skip 4. For 200, we check if there is anything less than or greater than, there is not. We skip it. By skip, I mean we set it to 1. Right? We set it to 1. For 1, we check if there is anything less than 1. Right? So there is nothing less than 1. So 1 is a smallest number. 1 is a smallest number, not in this, but in a consecutive substring. So there could have been a substring called 99, 100, 101, 102. That would be a different story. But for a consecutive substring, since 1 is the smallest, there has to be a substring with 1. So we just check how many are greater than there. How many of the numbers inside that particular, like particular array are greater than 1. By greater than 1, I mean greater in the sense the consecutive. So we first check 2 is there, yes. We check 3 is there, yes. We check 4 is there, yes. We check 5 is there, no. So what is the length? 1, 2, 3, 4. We update the max length as 4. Now what would have happened if we had 99, 100, say 100, 2, 103, 0, 1, 3, 2, 4, and say 68. Now at 2, we would have checked if there is anything smaller than 2. There is 1. What we'll do? We skip. Because if there is anything smaller than 2, so it's consecutive, right? So by smaller, I mean minus 1, by Larger, I mean plus 1, not in the literal sense. Like, yes, 0 is smaller than 100 too. Why are you not considering 0? Because they are not consecutive. We are only thinking about consecutive. So since 2 has a number smaller than it, it's not the starting. It's not the starting. It's not the starting. So we'll just go at the starting and then count, and then 2 will be there, present. So we have skipped 2. I will just mark the skipped ones in red. We have skipped 2. Undo, undo. We'll skip 2. Similarly, at 3, is there anything less than 3? Yes, there is 2. We'll skip 3. At 99, is there anything less than 99? No, there is nothing less than 99. So 99 can be the start of a substring. Now we check if there is anything greater than 99. Yes, there is 100. Is there anything greater than 100? Let's say 101 is also here. Yes, there is 101. Is there anything greater than 101? 102 is there. Is there anything greater than 102? 103 is there. Is there anything greater than 103? No, 104 is not there. So it is a 1, 2, 3, 4, 5. Now our max length is 5. Now this is our max length. Till now, 5 is our max length and the array is 99 to 103. 99 is done. 99 is checked. For 100, is there something less than 100? Yes. For 102, yes. Sorry. For 100, there is something less. For 102, there is something less. For 103, there is something less. For 0, there is nothing less than 0. So 0 can also be the start of another substring. Similar to 99, we check, go to 0. Is there anything greater? Is there a number, next number of 0? Yes, there is 1. Is there the next number? Yes, there is 2. Is there the next number? Yes, there is 4. Is there the next number? Yes, there is 5. Max length 5. Since already, so we'll do max of current string length, current subarray length, and already stored global max length. So obviously it will be 5. We go to 1, there is something, there is the previous digit of 1, yes. For 4, yes. For 68, no. For 68, no. We check if there is anything larger, no. So the max subarray from 68 could be 1. 1, obviously here it will not fit, but yeah, we have checked 68. We have checked it 68. Then for 101, it will again be skipped. So you can see all the numbers which are circled in green, all the numbers circled in green are the starting of different subarrays. From 99 we have a subarray with length 5. From 0 also we have a subarray with length 5. From 68 also we have a subarray of length 5. Suppose how we wrote it, we wrote 2, 3, 99, 100, 102, 103, 0, 1, 4, 68. No 101 is present, then what would happen? Less than 2, yes. Less than 3, yes. Less than 99, no. So 99 is a start. 99, 100, there is no 101. So 99 and 100. Less than 100, yes. Less than 102, no. So 102 would be also a start. Less than 103, yes. Less than 0, no. Less than 1, less than 4, less than 68. So this has a subarray of length 2. This has a subarray of length 2. This has a subarray of length 5. This is a subarray of length 1, which is the longest 5. So we will keep on updating the subarray length. So at 92, we set the max subarray length as 1 because at least there will be one digit subarray, right? Like if any digit is present, if it's not an empty array, then it is a subarray. If it is a consecutive subarray, so we'll store it as 1. When we go to a smallest digit, we'll update the subarray until which the consecutive digits are present. So for 99, we'd say 99, 92. So now the max is 2 for now. We go to 100, we go to 102, we again see the max is 2, so max stays as 2. We go to 103, we go to 0, the max is now 5, max is updated to 5. We go to 1, we go to 4, we go to 68, max is 1, but the global maximum is 5, so the current maximum is not updated. Let's see what the code is. Let's look at the code once. Let's look at the code. So this is the code. I will zoom it for you. So for I in nums, d of I equal to 1, right? A dictionary has been made, which is d of I equal to 1. For I in D, if I minus 1 not in D, what does this mean? If I minus 1 not in D, it means it's the start of a new subarray, right? Longest we've set as 0. I think there is, yeah, nums dot length could be 0, so it can be empty dictionary. So longest we've set at 0. Start of a new subarray. So now the current element is I, the length is 1, right? While current plus 1 in D. So as long as there is the next consecutive element, we'll keep increasing the length, we'll keep increasing the current value. So current is I, current plus 1. So I is, let's say, let's just print it. Print current value is current and length is length. Hmm, After if, oh, okay, my bad. There's an indent missing. Local variable current when it's just give me a second. When x this one. Let's add and longest and longest. We'll copy this and we will add this here. Now see what happens. This is a dry run. When it's 100, so when it's 100 for I in D, when it's 100, 1, 1, 2, 3, current value is 1 and length is 1 and longest is 1. Yeah. So when it's 100, the length is 1 and longest has been updated to 1. Longest has been updated to 1, so it's not reflecting here because longest the update is happening here. But when you go to 200, when you go to the next element, you see the longest is 1. You see the no longest is 1. Why is 4 not present in the longest? Huh. This longest does not make sense at all. Okay, when it's 1, so I'll just remove this also, it's getting confusing. When it's 1, so current value is 1, current plus 1 is 2. 2 is present in D, yes, increase the length, increase current by 1. Now what the current, now current is 2, is 3, current plus 1 present in D, yes, 3 is present in D, increase the length, increase current by 1. Now current is 3, is current plus 1 present in D, yes, 4 is present in D, increase the length, now current is 4. When current is 4, current plus 1 is not present in D, current plus 1 is not present in D, this loop is skipped. Now the current length we have is 4. Highest length we have is 4. For longest we say max of length and longest. So length is 4, longest is 1. Longest now it's getting to 4 and we are printing 4. So how we also can check this is if we write this thing current plus 1. So plus 1 and if you write this thing not this keyboard history. So current plus 1 value was 2, length was 1, current value is 2 and length is 2. Current plus 1 value was 3, length was still 2, current value is 3, length is 3 because length has increased here. The length increase is happening here. Current plus 1 value is 4, 4 in D, yes. Then current value is 4, length is 4. Current plus 1 value 5 is the loop has been exited. Current plus 1 not in D. Similarly, if you can see case 2, current plus 1 value is so 1 0 1 2. So 0 1 2 would be the longest. So current value is 1 and length is 1. Current value is 1. Current plus 1 value is 1. So current value would be 0. Here current value is 0. That's why current value is 1. Now after the increment, current value has become 1. Current plus 1 value has now become 2. And after the increment, current value has become 2. Current plus 1 value here would be 3 now. But since 3 does not exist in D, the length will not be increased because it does not go 3 when current is 2, current plus 1 not in D, current plus 1 not in D. So the output is 3, the max of length and the longest. Hopefully understood this one. We'll just submit it very quickly. Uh, this, this, and it's a good solution.